Hi everyone, my name is Degioanni. I'm the CTO and founder of Sysdig. So what I'm going to do is talk a little bit about how Sysdig got here and maybe a little bit of history with two goals. One is show you that I'm getting old. And the other one is, what Sysdig is today and the technology behind Sysdig is sort of an evolution and sort of the continuation of a journey that started quite a long time ago. So hearing about this journey from one point of view can be interesting, and from the other point of view allows me to then explain better what actually our technology is, how it works, and why it works in the way it does. So Sysdig is my second company. My first company was called Case Technologies. It was the commercial entity behind a very well-known open source network analyzer called Wireshark. I was involved in packets and packet capture since when I was in school. I went to school in Italy, Politecnico di Torino, and I started essentially building network analyzers and pieces of network analyzers when I was doing my graduation thesis there. That evolved into starting a company in 2005 with the mission of essentially being the commercial entity behind Wireshark. And that company was acquired in 2010. We became part of a bigger company called Riverbed, and while I was there, I started realizing that from one point of view, what we were doing was very valuable, but at the same time, the world was changing. Cloud computing was starting growing. A little company called .cloud was being renamed into Docker, and there was a lot of stuff going on, stuff for which I believed that the previous generation of infrastructure vendors and tools vendors was not prepared architecturally. So I left my previous job and I started my second company, Sysdig, in 2014 to try to focus on the problem of essentially solving, as best as I could, visibility for modern cloud-native infrastructures. My background is packets. I've done packets for the first 15 years of my career. I contributed personally to creating many of the workflows behind network packets. So I assume a decent amount of you here in this room and people online have had to do with a network and have used tools like TCP dump or Wireshark, and there are some very nice properties and very good reasons why we traditionally have used packets a lot to solve many problems, and we're still doing it today. Packets are information rich. So packets are these units that actually transport essentially the communication among different components on the network, and nowadays the little pieces of an application. So if you go inside them, if you decode them, if you unpack them, there's a lot of information in them. Packets see everything. I used to say packets never lie, right? Mm-hmm. Because you cannot hide a communication on the network. If something is listening, it will be seen, right? So there's the beauty of never missing anything if it goes on the network, of course, and being able to collect this without overhead on the applications in order to see what an application does. If you use packets, you don't need to link libraries, add sidecars, do instrumentation or whatnot. You can just sit, somewhere and look at what is happening, which also means that it's very efficient. And of course, packets are, for all of these reasons, at the base of many tools, right? So these slides shows few examples. There's many more, right? And each of these examples is essentially a full industry. We can safely assume that for each of the boxes in this slide, a non-negligible side enterprise has at least one product from one vendor, possibly more than one, for for each of them. And they're all based, if you think about it, on the same unit, right? Different tools, very different use cases, but the same data and information unit that I was describing. Now, that's great. Too bad. Packets are dead. This is a little bit of a controversial statement, but why am I saying this? You know, I spent most of the early part of my career in packets, so I have quite a bit of experience with this, right? And the reason why I was saying that I was inspired to start Sysdig is because, from one point of view, I've always been in love with the properties of packets. I've always been in love with the ability to take a capture, you know, and then sharing a capture with somebody else and being able to have this piece of information that can be decoded in a million ways, right? At the same time, I started realizing, like, most of the time when we were selling, you know, packet-based networking tools, the collection was based on a couple of techniques. One is the spam port of the router, right? So the router has a specific port that can be programmed to essentially mirror all of the packets. You can sit there, you can have multiple tools sit, you know, and listen on this port, and they see everything, right? And the other one is tapping the network, you know. Somehow it's more complicated than that, but you can imagine having a wire, putting something in this wire and being able to see the activity similarly. Where is the spam port? In cloud computing, where you're renting instances that are floating on top of Amazon or Google or Microsoft or IBM or whomever network, you know? Where's your spam port when you are maybe running an orchestrated Kubernetes infrastructure and you are running maybe 200, 300. I've seen people running 500 containers on a single machine. There's a bunch of stuff going on, you know, on that machine without every single packet hitting a spam port, hitting a router at all, right? So all of a sudden, the best property of the packets, which was packet never lie, is not true again. Sometimes packets can lie because you can miss some, you know, because there's encryption, you know, and all of the data inside the packets is hidden, is trapped by encryption, right? So all of these made me think, okay, the solution of sitting on a router is just not going to work anymore. It's unfortunate because you could build so many beautiful tools on top of that. Let's go back, you know, to the drawing board and let's try to figure out what to do. So back to the question, you know, Suresh opened this presentation with this. I just want to reiterate the question. You know? In a multi-cloud world with opaque containers and no network boundaries, how do we recreate the magic of network packets? And this starts from an inspiration that I had together, you know, with the people that started Sysdig together with me, which was like, okay, now we need to sit, you know, closer to the endpoint, and if we want to do that, we need to find a data source that is similar in terms of properties, right? And initially, now Sysdig does more than that, and I will show it to you, but initially, what we decided to explore was tapping into the kernel of the operating system and being able to extract metrics from there. In particular, for example, system calls, right? And treat them in a way that is similar to network packets. Before I go into describing exactly how we do that, I just want to spend a second on what I often call the Sysdig way. This is actually not something that I coined, but one of our chief architect, you know, his name is Gianluca, when he works on his projects, he uses this, you know, like, are we doing things the Sysdig way? And Sysdig way means easiest possible instrumentation, no state-changing components, no blind spots, and high granularity. These are things that are definitely nice to have. But in modern infrastructures where you want to compose your application by picking pieces here and there, you know, Docker Hub, you know, your private container repositories, Chef and Puppet, you know, all this kind of stuff. So you want to be as free as you can to just take pieces and compose them to build your software, to build your application. And these pieces are small. There's a lot of them. They move very quickly, and they are sort of opaque. These kind of properties become sort of a requirement. It's very hard to accomplish, you know, the proper visibility without meeting these goals. So From the instrumentation point of view, this slide is a simplified depiction of a machine. And on this machine, there are 3 containers that are running. Sysdig, of course, supports both containerized and non-containerized workloads. But for the purpose of this description, I'm using 3 containers. And the way you deploy Sysdig is typically you run 1 more container on the machine. So deploying Sysdig means typically telling an orchestrator like Kubernetes, make sure that there's one of the dark gray Sysdig containers running on each of my machines. When you do that, this container detects the version of the operating system and instruments the operating system in a way that we create essentially a layer between the machine and the software, the containers or the processes that are running on top of that. This layer, nowadays, we base it on a technology called eBPF, which stands for Extended Berkeley Packet Filter. And it's sort of a virtual machine that you can use to run safe scripts inside the kernel of the operating system. I was an early contributor to the original BPF, which was a packet filtering system in the BSD operating system. And now we've been contributors to eBPF to make it possible to run, for example, in the Linux kernel, this kind of advanced functionality. The instrumentation based on eBPF sits between the processes that are running on the machine and inside the containers and the operating system itself, acting in practice in a way that can really be compared to a spam port, to a modern 2.0 version of the spam port, with the difference that by sitting in the operating system, it can capture much more than just packets. So, of course, everything that goes in and out of the network is captured through this mechanism. But by being able to capture every single system call, we are also able to capture, every single read and write to disk is a system call. Opening and closing files, inter-process communication, executing a program is a system call. So by intercepting at this level, it's possible to get a very accurate picture of what's the user activity inside the machine. And networking, a bunch of stuff, right? So there's this way that in spirit and in philosophy is very similar to collecting packets, but collects much more and much closer to the application in a way that is, let's say, much more application-oriented. This is, yes?
Question about that. So, I mean, obviously, that one container that's running Sysdig has an immense amount of information it's collecting from these other sources.
Correct.
A lot of that information could be very sensitive.
Yeah.
So how are you enforcing security on that container to ensure that it is a legitimate Sysdig container and it's not some third party who's kind of piggybacking on it to pull all this information?
Yeah, before answering this question, which is an extremely good question, I just want to come maybe from the top down and talk a little bit. Yes, it's absolutely right. Essentially, you're trusting this darker gray container
a lot of trust.
to do a lot of stuff. At the same time, think about the way you were doing this before in maybe physical and virtualized infrastructures. What you were doing was for each of you remember there were many categories of tools like monitoring, visibility, troubleshooting, forensics. For all this kind of stuff, like on a regular VM, what you do is you install something, a package, right? And each of these packages typically need to have some kind of higher privileges because they need, your protection, your firewalling, your runtime, detection, your monitoring, all of this kind of stuff need to have deeper visibility. So you ended up having, a plethora of different components, each of which with higher priority running on the machine together with your application inside the same VM, right? What an approach like this allows you to do is take all of these and instead of having them run inside every little container side by side with your application, you're sort of extracting all of them and putting all of them here. Also meaning that this guy is in a separate container, which means, typically the lighter color guys are the guys that are exposed to the outside traffic and the threads, while this guy is only outbound, right? So first of all, what you do is you take all of this stuff and you put all of it in a single place, and then you put like a layer of a container around it. It's still dangerous to have that container, but at least you know what you have. You only have one, and it's in a place that is a little bit more isolated, right? Mm-hmm. Now,
please, go ahead.
Yeah, at that point, of course, you need to be very careful about what this guy does. For example, one of the reasons why we're using eBPF for this, and we're transitioning, originally we were using a kernel module, right, for this purpose, is that eBPF is much safer. There's like a validator that validates a script that goes in the kernel before you run it, so that the script can, not cause damage or steal, sensitive information from the kernel. And then, of course, we're very careful about the components that we put inside our container. We're very careful about the communication, about the encryption of the data, about what we do, in place, what data we transfer to our backend, and we try to, of course, pay the most attention. But again, if you look at the high level to this problem, the user has to worry only about Sysdig, which hopefully is good, instead of having to worry about 10 different vendors.
Okay.
Yes.
Could you just clarify for me, please? eBPF runs in the container?
No, eBPF runs underneath the containers in the kernel of the operating system, at a layer that is sort of, you can imagine where like the file system or the TCP stack is. So underneath. So the beauty of this approach is that instead of having to put something inside the container is completely clean. You can just do a Docker pull of a container from the Docker Hub, run it, don't do absolutely anything to it, and the demo will show it to you, and you get full visibility because essentially we see inside the container from the underneath.
If I may just follow up on that. So I take it runs at ring 0 in the operating system.
Correct.
Yeah.
Yes.
So in instances where people are running containers in VMs for OS isolation, how do you configure in that case?
So the question really depends, because running containers in VMs can mean very different things that range from we have many customers that adopt the so-called lift and shift approach, in which they just take an application that was in a virtual machine and they package it in the VM.
Correct.
Or just like packaging, and then just run one of these per virtual machine. That gives you isolation, but doesn't really give you a lot of the advantage of containerization. In that case, essentially what you do is you run Sysdig inside this VM. So at this point you would have less one of the dark gray containers for each of the light gray containers.
And in that case, sorry, I don't want to interrupt, but in that case, you still centralize collection?
Correct, absolutely.
Okay, good. That was where I was going with that question.
Which the demo will show you. But all of this data, of course, this dark gray container does a lot of stuff locally. For example, like from the security point of view, looking for anomalies and stuff like that. And then also collects and summarizes data that then sends to our backend. And our backend gives you an end-to-end view where all of the data coming from the agents goes to a single place.
Thank you.
eBPF, is that included in most Linux distributions now, or is that something you have to add to your worker nodes as part of that?
It is included in every single distribution nowadays, at least relatively recent distributions of Linux. But what we do essentially, eBPF is just imagine having a virtual machine, something like, let's simplify it, like a little JVM, running inside the kernel of the operating system, which lets you essentially run scripts in a way that is safe and is essentially just-in-time compiled when it hits the kernel of the operating system.
Yeah, I'm just trying to get it's a dependency that you need to make sure it's there on where you're deploying Sysdig into.
So the JVM is always there.
Yeah.
What Sysdig provides is the scripts, right, that do what exactly we need to perform these tasks.
So you mentioned this is included in most recent Linux distributions.
Yeah.
How about Windows?
So Windows is a different beast, and with Windows, essentially you solve these problems with essentially device drivers. or connecting to specific, functionality, for example, for the network Windows as a specific framework that you can use to extract this information.
But you do support Windows?
We have Windows on our roadmap.
Okay.
Yeah.
With a port of eBPF or with something like WinRM?
No eBPF on Windows.
Like
so
WinRM or something
more like
that?
a traditional kernel level instrumentation through a device driver. All right, that's the core of the way Sysdig collects the data. Over time, we've added a lot more to that. So from the data collection, now Sysdig does, for example, image scanning for container images. It interfaces. We were talking about Istio before. We get data out of Istio. We get intrusion detection data through Falco. We get Prometheus data. So there's a lot of richness, additional richness in the data that we collect. Similarly, we extract data from cloud providers and applications and stuff like that, and that results into a bunch of very rich functionality. So the data set started from like eBPF as system calls, and nowadays Sysdig essentially taps into every single source of data for modern infrastructures and brings it to a single place. At the same time, it's important to point out that most of this data collection for us is open core. So all of the technology that I just described to you, pretty much all of it is open source. And in addition to that, as I was saying, we leverage technologies like Prometheus, like our own Sysdig Inspect and Sysdig Falco, and like Anchor to essentially create an ecosystem of open collection on top of which we build our commercial tools. One more element of technology that it's important to talk about is what we call service vision. So now this diagram shows more than one machine, and each of these machines is running multiple containers. So, in a situation like this, of course, it's important to collect data from each single container in a way that is as horizontal and as granular as possible. But it's also true that different people in the organization will need different subsets of this data. So typically, for example, if we imagine this is an orchestrated Kubernetes infrastructure, we will have a pool of machines that are running different services, and maybe the database administrator only needs and should see the dark gray, the dark blue containers here in this picture, right? While the application team X should have visibility and data from different containers with a different type of granularity. While maybe you have a PCI-regulated component of your infrastructure, and this is still, a different set of containers. They all share the same infrastructure, and by the way, maybe your infrastructure administrators would prefer to see things from the host point of view, right? So how does Sysdig does that? We have a technology that is called Service Vision that takes all of this super rich data, correlates it with metadata coming from AWS, Kubernetes, Azure, Mesos, DCOS, and so on. We support essentially, we were the early companies that support all of these essentially cloud and container environments. So we added support for all of these environments so that we are able to both at the configuration and the setup level and at the data consumption level to always expose stuff at the service level. So when you create an alert in Sysdig, or when you see a metric in Sysdig, or when you set up, for example, a notification, you can do it for physical host, but you can also do it for example, for the Redis servers that are in production for the credit card validation service, And then Sysdig will worry about finding these entities and applying different policies and extracting different data for these different entities and expose different slices of this data to different users through a concept that we call teams. All right? So now you have the data collection and the service integration and the service vision. All of these go into one single framework, which means only one agent, as we were saying before, only one backend, but then multiple pieces of functionality on top of that. So, in other words, if we go back to this slide, it's like containers and microservices and cloud native and the innovations brought by Sysdig allow you to take what's in this slide, which before, you had 3, 4, 5, 6, 7, 10, 12 different vendors to support this functionality with 10 different agents, with 10 different, security posture, like possible concerns and so on, and essentially aggregate everything into a single platform. So Sysdig is a monitoring tool, yes. Sysdig is a troubleshooting tool. Sysdig is a runtime security tool. Sysdig is a forensics tool, all in a single platform, all with a single overhead in the instrumentation, all with a single source of risk, all with a single backend that you need to deploy. And then, a la carte, Sysdig can offer you in an integrated way different views on the data, which is always the same, because, I was selling to the enterprise, and I remember everybody had like 5 appliances with the same data, exactly the same data, all capturing the same packets, all capturing all the same net flow, but one for forensics, one for performance, the other one for troubleshooting. Imagine merging everything together, thanks, to the fact that in the cloud you can have like all of this data in a single place, and then imagine having a single tool that offers all of this functionality for the whole life cycle of the application: build, run, and respond. That's Sysdig in terms of technology.
So, it's awesome to collect all this information in one place instead of having, like you said, 5 different appliances that are all collecting the same information and storing it separately. But I don't necessarily know that one tool is going to be ideal for doing the analysis of that data for each different group. So security has one set of requirements, performance has another.
Yeah.
So the data that you're aggregating, is that open and available for other tools to analyze and pick apart in a way that makes sense for a particular job function?
Yeah, look, you're asking a question that is so good that pretty much all of our enterprise customers are asking us that question and giving this to us as a requirement, right? So it's very natural, especially, you want this to act as your repository, and of course we want to offer the users the best possible workflows for this, but we also want to make this data as accessible as possible, and our product is designed not only through APIs. Of course, we have APIs that you can use to consume this data, but we also have like an architecture that embeds, for example, that is able to push all of this data on, like, for example, a Kafka queue, so that you can tap into the stream real time as it happens and do what you want, with this kind of stuff. So the product is really architected in a way that from one point of view, it's like we store the data for you and we let you ask questions with our own user interface, but at the same point, it's like the collection is really a big value. We focus on the whole life cycle, starting from collecting the data to a UI around it. And so at any point in this life cycle, we want to give people taps.
The question that was asked earlier about can we tap into the data, one use case is a customer that has events feeding into their SOAR platform, and what they want is they spend time once an event is created around enrichment with other contextual information they need in order to analyze that. And so the question they're asking is, even if the event was not created, the detection was not by Sysdig, but the detection was by some other tool, can you give us enrichment data for that event without us having to go extract that from hosts and so on and so forth, right? So it's much more of we think of those as feeders, as recipients of our data, or enrichment of the data that's in those platforms.
Okay, but I didn't well understood, but at the beginning, you also were talking about forensic with the data, and that's what we do with SOC.
Yeah.
Go ahead.
No, forensics use case is absolutely very, very widely used use case for Sysdig. And there, again, typically the goal is, from one point of view, offer visibility that is as granular as possible, and the demo will show some of that. But it's also important that that kind of visibility, typically when you are in forensics mode, you are focused on a very, very specific thing, and you want as much detail as you can. So typically the workflow comes maybe from your SIM tool, and your SIM tool allows you maybe to do like the high level, okay, there was somebody stealing my data, I identified it. Now let me jump into Sysdig, and Sysdig can tell me exactly which files were touched, with which data they contained, and who stole them, where they brought them, and all this kind of stuff, with the granularity of essentially the single payload, even if the container is already gone. And this is typically integrated in a workflow that maybe starts, again, from whatever, Elastic or Splunk,
You mentioned you're using eBPF for that visibility within the containers running on a host, but you've got some enforcement pieces there, so we're actually doing things on the host. How are you orchestrating that?
Yeah, so eBPF is used exclusively in a passive way. So we don't do yet enforcement using technologies like eBPF. So our enforcement is more like a consequence of insights that are coming from the stream that is collected through eBPF, and then we enforce using different mechanisms. For example, I don't know, blocking a container by using the Docker API or stuff like that.
Okay, so you are actively doing that, but there's a number of different ways.
But we're not filtering, like we're not making the single system call fail, like the open to the file fail through eBPF. It's more like we use enforcement methods that are separate from that.
Okay. So can you block things like a container being run on a host if you've said it's vulnerable, exactly. I don't want that on that host, or it comes from an untrusted registry?
Exactly.
Okay.
Precisely.
And kind of talking about that architecture model, do you have any views or any plans to give some of this visibility in a serverless landscape as well?
In a service landscape?
Serverless.
Yes. There's work in progress at Sysdig. Essentially, again, it's on our roadmap during 2019 to be able to essentially offer similar functionality for places, for example, Lambda, where you're just running the function, and we're exploring and implementing different technical options to do that.
Because you kind of get even less visibility at that level
exactly.
of what the packet's dead, and then you're like actually the platform, the access to the operating system is gone as well. But you still, it's even more of a problem to understand what on earth's going on. So yeah.
And the Sysdig way becomes even more important, right? Because you're just running a function. You cannot deploy, like a
Docker, a daemon set.
Exactly. Or whatever to monitor it. So it's very much a problem that we're working on.
Maybe my question is a little bit more basic than the others. On the worker nodes for y'all's solution, what kind of overhead have y'all seen with Sysdig looking in and gathering aggregating all the data and whatnot?
Nothing. No. Of course, answering this question in detail is not trivial. Because, as you can imagine, this is a system that intercepts essentially events that are happening, and the more of these events there are, the bigger the overhead it is. Mm-hmm. So, with the amount of time that I have here, I can only give you like high level, and then of course I'm able to dive deeper in the details. But typically, this is designed to have an extremely low overhead in terms of instrumentation. My PhD was high-speed packet capture on 10 gigabit networks. A lot of the philosophies that I've essentially used during my PhD are used here essentially to capture this data from the kernel in a way that is as fast as possible. On a typical machine, you can expect to see a few CPU percentage points of one CPU used by Sysdig. Typically, like our commercial agent has a set of mechanisms that start subsampling the data optionally and based on the threshold that you set. For example, it's set by default at 5%. If the CPU of the agent goes beyond 5%, we start reducing the kind of data that we collect to make sure that we never go beyond the threshold.
Okay.
One more question.
One more.
Maybe two. You showed you've got the kind of data plane with a daemon set, say, on each worker node. But where is the control plane for that? Are you running as a container-based application? How does that break down?
Yeah, you will run a Sysdig backend. So essentially, the architecture is there's one agent on each of your machines, not in each container, in each machine, and then there will be a backend somewhere. Sysdig offers two flavors of our backend. One is SaaS. In that case, we run the backend in the cloud, and you just point the agents to our backend. And the second flavor is as software, and in that case, you deploy our backend as a piece of software that typically, since the majority of our customers are modern cloud-native Kubernetes-based users, it's typically Kubernetes deploy. So we have a set of scripts that allow you to deploy our backend on top of Kubernetes.
And is there any kind of caching of rule sets or configuration or anything on the agent locally, so that if that control plane or the communication is interrupted, then you can still enforce the security locally?
The answer is yes.
Okay.
Both in terms of pushing configuration to the agents and in terms of the agents sending the data out to the backend. So there are buffers and caches that allow essentially our agent up to a certain point to operate even if the connection with the backend goes down.
One last question. Do you have, are you doing anything around secrets management, or is that something outside of here in terms of pulling secrets from, say, HashiCorp Vault or CyberArk or something like that and putting them into containers, managing, or the Kubernetes secrets themselves, which are notoriously poorly?
Yes, so this is not an area where Sysdig is active at this point.
Yeah.
We might in the future, but at this point our product doesn't do that kind of stuff. We focus more on from the security point of view, runtime detection, runtime protection, and of course image scanning.
Where you've shown your product set, and actually if you're in this world, you're tending to bring lots of different products together to do these things. So that's not necessarily a bad thing, it's just understanding
that's the
kind
missing
of,
one,
where
the
this,
puzzle. Yeah, absolutely, yeah.
Just one quick one from me, sorry. I'm running out of time. You mentioned PCI compliance.
Yes.
Do you have details of which areas of the standard you are helping solve the challenges? Because one of the areas I'm looking at right at the moment is, building compliance in containers is different, completely different. So.
Knox, do you have a microphone? Do you want to take that one?
I don't have a microphone, but across.
Hang on, they'll get you one.
There's a couple different areas that we'll focus on. So some are in the early sections, we're having dynamic network maps of all the different connections. A lot around the modification of system binaries, auditing any user activity, as well as we've incorporated the CIS benchmarks into our product. So a lot of the different hardening standards that you'd also use for PCI controls are baked into Sysdig Secure.
Okay, brilliant.
All right, who wants to see the product?
I want to ask one more question. So what about, I'm trying to figure out how this all relates to standards like open census or open tracing.
Yeah.
Because they kind of, they are an open way to collect data too.
Yeah.
Maybe more from an application level, actual instrumentation.
Yeah.
But I kind of want to get a feel for, how is it different, how is it similar?
Yeah, this is mirrors a little bit the answer that Suresh gave earlier about Istio. So for some of the stuff, our products act a little bit as something that can be an alternative to the standards. So for example, in terms of open tracing, Sysdig for some kind of like the basic tracing and metrics is able to do it without even needing to use open tracing, right. And that in the spirit of having all of these with zero kind of instrumentation complexity. At the same time, we integrate with open tracing, we integrate with open census to collect this information, and when they are there, we take advantage of them to make essentially our data even better.
Okay.